Hello, my name is Peter Holtkamp. I'm Managing Director of ASAPIO based out of Munich, Germany, and I'm responsible for our cloud integration division, which is, let's say, very well connected to Solus. So we are a long-term Solus partner for event-driven architecture, and we want to talk today about how EDA can simplify SAP system integrations. So the content of this will be more about, okay, what is the perception of SAP customers when they talk about event-driven architecture? And I think there are a couple of fears on the table, which we want to take away, and where we want to explain that the, let's say, approach for event-driven architecture can be just the opposite. That can be the solution for performance impacts and for system problems. And I think we want to dig a little bit deeper into how our customers experience that thing and how we can, let's say, facilitate EDA to the benefit of our customers. So let me jump to the first slide. So digital transformation is something we talk a lot about in all these conferences where we are all on site and we discuss things back and forth, but still a lot of companies are not aware of the fact that digital transformation is unavoidable. So anything that you do in your system, let's say 10 years ago, we did a lot of printouts with our customers. We had purchase order printouts, invoice scanning, and all these processes. And I think when you want to be successful in the market, these times are over, and we see a lot of customers that really understand that digital transformation is key to success. And for that reason, these customers really implement all these, let's say, new interfaces. And when you talk about your server infrastructure, SAP systems are a very central application in this whole infrastructure. Plus, what we also see, we see a lot of hybrid landscapes inside the company. So when you talk about, let's say, the infrastructure that you had a long time ago, you had one server for SAP, you might have had a different server for your production or something. Now we talk about much more hybrid landscapes because some applications are still operating on your local server infrastructure, but you still have a lot of SaaS offerings where people have moved applications into the cloud. And these different systems have to talk to each other in order to have a seamless process operating for your business. What we see is that these integration capacities for the SAP systems are the bottleneck for the organization. Why is that the case? At the time when these systems were implemented, the need for, let's say, digital interfaces were far less than what we see today. And again, as we said, the number of interfaces is increasing. And for that reason, we have to see how this interface need can be handled without putting too much load on the system to make it a bottleneck for the organization. If you use the wrong approach, and we'll try to explain that in this speech series, this often leads to really higher costs and poor outcome. Poor outcome means you can't build interfaces that you need. You reduce the performance of your SAP system, and your customer and your internal customer base and your employees will suffer from really poor performance. And that's what we don't want. We want to be able to operate digital, but we still want to have a really good performance for our staff. What drives integration for SAP customers? So when you think about what most customers operate in their SAP system, we talk about, I mean, all different applications. So from sales, procurement, logistics, we talk about production, warehouse facilities, and all these, let's say, applications inside the SAP system don't operate locally anymore. I mean, when you talk about production, you talk about collaboration with your suppliers, with your customers. You talk about production planning numbers that you exchange. When you talk about procurement, you talk about your first and second tier suppliers, which you want to, where you want to tell them what the requirements are for the next weeks and month, or logistics, warehouses. You exchange data everywhere to the external world, but also internally. You talk about things like your IoT, for example. So you have a lot of local sensors. And these sensors can be used in order to facilitate predictive maintenance inside your SAP system. We have online shops. We have internal shops, like for your staff to procure things. We also have cloud analytics, which is very important. When you think about cloud analytics, what they often try to achieve is they want to measure the overall process performance. And if you want to measure a process performance, you have to take all your, let's say, existing infrastructures under consideration. And some of that stuff sits in SAP, some sits somewhere else. So you need the connectivity into SAP in order to retrieve that data for cloud analytics, but you also have to exchange data to other systems in order to have the end-to-end process analytics. Supply chain collaboration is an older one, which is used a lot in the automotive industry, accounts payable. The list is endless, just a couple of examples. Question is now, if you want to achieve all these connectivities and these exploding number of digitalizations and interfaces, what are the key requirements in order to facilitate that in an SAP system? So first thing is that every customer asks us, event-driven sounds like totally unstructured system load. So how can we reduce the impact on the SAP performance system? And how can we also keep the system performance under control? Because we don't want to lose it. That means like something's happening in the SAP system that has an impact on the performance anyway. And then you put the extra event-driven architecture on top of that and even reduce the performance. And that's not the approach. We talk about that later. But low impact for SAP system performance is key, and as said, most of the time, the first question. Second thing is we have to be agile. Why agile? Let's say SAP lifecycle is much slower than most of the applications we talk outside of SAP. So an SAP project, I mean, I do SAP projects for 25 years now, has a duration of 6 months to 24 months. So slow moving, you first write a blueprint, then you think about what you want to implement, you implement that, so it takes forever. When you talk about external applications like online stores, analytics or something, they require changes in the infrastructure and the data structures on a weekly basis or something. So you have to be able to facilitate these needs. You need the agility, you need the speed to market. And that's why we have to use a no-code, low-code implementation approach, because if you want to code all these interfaces, you're too slow, and this is too much effort for you to build all that stuff. Then you need a support for extendability. What does that mean? It's not that every system, SAP system, looks alike. So one of the reasons why SAP was very successful is because they facilitated SAP customers to customize the system exactly to their processes and their needs. So the integration approach that we take has to be able to support all these extensions and all these customer-specific requirements to be exposed to the outside infrastructure. So it cannot be a static approach where you say, this is how the interface is, take it or leave it. I mean, will never fulfill the need for the customers. So we talk about a build to purpose interface more than okay, this is it and you got to take it. We talk a lot about S/4HANA, we talk a lot about RISE and all these new server structures of SAP. Of course, it has to work with S/4HANA. Some customers are already in S/4HANA, others definitely have S/4HANA in front of them because the support for SAP ECC is limited and everybody will be going into S/4HANA. So the approach has to be operational in S/4HANA because you want to do an invest and you don't want to invest that thing again. Scalability is important. So adding extra interfaces and also having the interfaces capable of running high data volumes is very important. High data volumes can be two things. High data volume can be, you need an initial load. We had a customer who needed 250 million order entries in an online store. So initial loads are high volume. We want to talk how we handle that, but it can also be something like you operate an MRP in the evening, and out of that MRP, you've got 20,000 PRECs changed. And so you want to expose that changed planning data to your first-tier suppliers in order to have a good response time from these guys. So scalability also comes back to the first point of low impact for the system performance. Very important is a unified approach. So what we see right now in our customer landscape is they have a lot of, let's say, different integration approaches, either from external service providers or even inside SAP. There is no harmonized approach currently. So you have a lot of different ways to integrate different SAP applications and then plus other ways to integrate non-SAP applications. Problem is, you want to keep control about what you're doing, which means you want to operate these systems, but you also want to see how they all interact with each other. You got to schedule them in dependencies and stuff. If you have different approaches, this is hardly doable. And this is why customers have bad performance, because they can't control when what is done, and then systems just get specific time frames when they totally overload. This is a very important one, application integration. What does that mean? So most integration tools that we see, change data capture tools and also middlewares, go and allocate data from the SAP database. When you allocate data, that's helpful for some interfaces, but what we see is, what is an SAP system? An SAP system is the combination of SAP database, where you store the data, with the application logic that you have inside the SAP system. Let me give you an example. I mean, available to promise. So you want to understand how available this product is. SAP has available performance strategies, and the strategies can be customized. They also pretty often have custom coding in there, but you can define which goods intakes, ASNs, whatever reservations or something are taken under consideration if you want to expose the available to promise quantity, for example, to an online store. So this is nothing you can ever just read from a database. You need the combination of a database with the application layer in order to expose this kind of information to the external world. So just going on the database is good, but in that case, you would then have to rebuild the smart logic that exists in the SAP application in order to utilize that data in the external structure. And this is most of the time hardly doable because it's a very complex application. It has a lot of logic in, and this is where really the value comes in order to not just have stupid data from the database, but really utilize the smart logic of an SAP system in an external structure. Why is SAP integration so complex? So we talked to a lot of customers who are suffering by implementing, let's say, distributed landscapes. I mean, a lot of cloud implementations are suffering and escalated, and we hear a lot of, let's say, bad news about implementations in that area. Why is that the case? So first of all, when you want to connect to an SAP system, the number of standard APIs is fairly limited. So they are there, but they are there in a way as SAP has thought them in a best use case, but it's not a built to purpose. So what you have to do then is, I mean, you have your use case on the external server, and then you have to see, okay, what might be the best fit as an API that's existing. And then you have to customize that API with custom coding, custom logic, and that can be really complicated. Or even worse, there's no API for your use case, then you have to build that API from scratch. And then you have to see how that API implementation approach really fits into your overall operational infrastructure. Second thing is, we talked about that custom extensions. So non-SAP is alike, system is alike, so they all have their own customizations in place. So you combine the SAP exposed APIs with your customizations, and it doesn't fit together anymore. So there's a clash. So the need for a build-to-purpose interface is also due to the customizations in the system, because you have custom code. You might have some application extensions that have a completely different logic than SAP has in standard. And this has to be facilitated in order to really take the logic to the external server infrastructure. And then, of course, as we said, the application logic itself. So we need the logic from the SAP system. Let me give you another example. So you want to connect an online store to, we've seen that with our customers, they want to connect an online store to an SAP system. And then you say, okay, you just take the price of the product. That's not how it is. So pricing in SAP is extremely complex. We once had an automotive customer who was programming price conditions in SAP for 2 years, because price differentiation is for some industries key in order to be successful in selling the products, which means you have different prices in different areas, you have different prices based on the size of your customer, or there are a lot of implications on the price that you put on your online store. And this is something, again, you cannot read from the database. You need this whole condition technology inside SAP, a lot of logic, but this is easy to achieve because the combination of SAP coding and the database is there, and you can just utilize that. What can EDA do? And we don't only talk about EDA, we talk also about PubSub. So what we try to achieve is, pretty often you see that SAP systems are connected peer-to-peer. So you have one SAP system, you have 15 different external servers, and you build an integration to that server, to that server, to that server. But you don't really use any synergies. So what we see very often is you expose the same data several times. We even see that for application link enabling, which is the SAP, let's say, technology to distribute master data. You build an IDOC for all these systems. So we had a customer who said, okay, I'll change the material master and I expose it to system A, B, C, D. So all peer-to-peer interfaces which have a significant load on the SAP system. Why would you do that? What you can do is you can just say, okay, when something happens inside that SAP system here, you just expose that information once, because it doesn't make it better if you expose it several times. And that's where the event broker comes in place. So what we do is we create via the event a payload. That payload is then exposed to the broker, and that payload is extended by metadata. So which means we build a dynamic topic structure. So you can customize the structure of that topic, which means you put the sales organization of that order in, you put the responsible seller in, or whatever. I mean, whatever kind of information you want, you can take it out of the payload and put it into the envelope, into the metadata, and then you expose it to the event broker. Once you get a response code 200, which says the broker has received the data, and you're done. What then happens is all these different subscribers that you have in the network can then say, okay, which topics are relevant for me to consume that piece of information. They can consume that piece of information, and the event broker is fully responsible end to end that this information is definitely loaded into that next server. What's even better is you can also build, let's say, distributed infrastructures. So it's not only that you have a local event broker, you can interconnect different locations, different areas in your company or something with another event broker where you have a communication broker to broker. And then that broker again has the information and can send them out to other systems. So this whole effort of looking into this whole infrastructure and sending this information out is not existing anymore. So just deliver it once. And this is where we say EDA and PubSub can solve performance problems, because just distributing it once versus distributing it 15 times, 20 times, or whatever, or on demand, is a completely different story. And most of our customers understood that, and after they implemented the infrastructure, they've seen a significant improvement in the system performance, though they do event-driven architecture. So what are the benefits? So first of all, we decouple the creation of the data, the event and the payload, from the consumption. So we just put it to the broker, and the whole consumption logic, let's say one of the 15 receivers is not ready to consume, you have a connection breakdown or something, none of the SAP systems problem anymore. You've exposed it, you've got 200 return code, and you're done. So you process it just once, so you don't have these one-to-one connections anymore. And by doing so, when you really think about the infrastructure, you have a lot of one-to-many interfaces, and you hardly have one-to-one interfaces. So, and all these one-to-many interfaces reduce the payload to the performance impact to your system. And if you really run an analysis, you will see how that could really solve a lot of the problems that we currently have. And it doesn't only solve the problem, it means reduced payload, reduced effort on the server infrastructure, but faster deployment of the information, because you don't have batch jobs exposing that information. It's real time. So you push a button and it's there. There's no latency anymore. You can still run the interface in background mode, which means you can, let's say if you run an MRP, you wait till all these 50,000 PRECs are updated, then you run an aggregated mode, but it really depends on the use case that you have, which latency is required. Okay, so how do we do that? So what we normally do is we have an add-on, and that add-on is installed on an SAP system here. So we don't talk about a middleware approach or something, we really talk about an approach with an add-on that is integrated into your existing SAP server infrastructure. What does SAP system mean? SAP system means it can be an ECC system, can be an S4 system, but it can also be other system types which are NetWeaver based, like an HR system, HCM, which can be a supplier relationship management system or whatever. And it's all the same approach. It's all the same add-on. And what we do is, due to the fact that we sit inside the SAP system, we have access to the application layer, which means the ABAP layer, and access to the database layer. So what we do is we define an event and we separate the event creation from the payload creation. So first of all, you define an event. You have more than 6,000 events pre-existing in the SAP system, which is from change documents, it's from output determination, it's status management, it's logistics information system. We can name a lot of these applications. So just by configuration, you can define an event relevant for the integration add-on. Once you have that event, you then go and create the payload. How do you do that? So you go to the application layer and you create a database view. And the database view can then select data from the database itself It's auto-formatting that data into a hierarchical structure. So let's say you take some data from the PO header, some data from the PO item. It will automatically create a hierarchical JSON structure for that payload. And if you then need extra information, let's say for the smart pricing, as we mentioned in the beginning, you can say and include this little portion of ABAP coding in there, where you then call the real-time pricing for that application. So it's a hybrid, a combination of database information and application information. Once we have the data selected, we connect it and send it out to the Solus PubSub. And it's then meta tagged, as we said, so you can then take data out of the payload and put it into the frame of into the dynamic topic of that payload. So Solus can then PubSub it to the corresponding consumers and project producers. What we do is we have the capability to run this multi-threaded. So let's talk a little bit about that, because that has a significant impact on the performance. So when you do massive loads, you allocate resources in an SAP system. An SAP system has a defined number of work processes that you can allocate. And we are able to run multi-threaded, but we don't run uncontrolled multi-threaded. So we define something. SAP has an old technology they call server group, which means we define via the server group how many parallel processes we can allocate in order to transmit that data to Solus. So we say you get 40% of the work processes, but you got to keep X percentage alive, and you got to do. So it's really a rule-based engine. And inside that limitation, we can transmit data extremely fast, because Solus can take nearly unlimited data. It's just unbelievable. This engine is extremely fast. So we now have the capability to utilize in a very controlled way the data out of the SAP system to be transmitted to Solus, and we still never lose control. So if something else happens in the system, we reduce the performance of the integration add-on. If not, we add it. The reason why we are fast is because we run very lean code. So the way this whole thing is implemented is we try to, our developers have to justify for every line of code. That's just performance is key. Plus, due to the fact that the implementation of the interface is codeless, which means you just define it, we also have your customizations under control. So feedback from our customers was that was the fastest interface they've ever built from a build perspective, from an agility perspective, but also from an operational perspective. So what's the conclusion? So when we include EDA into SAP systems, we see this highly beneficial. Why is it highly beneficial? We reduce the payload on the SAP system, we improve the latency of the interfaces, and we improve the overall integration performance by multi-threaded approaches via server groups in a very controlled way. So ASAPIO and Solus, the way they collaborate, we don't want to dig too deep into technology, but we have high availability connectivity. We've got the dynamic topics, we've got the low code, no code integration approach, we've got the application layer. And our two engineering teams work very closely together in order to enable this whole integration. We're both SAP partners, so we both have products inside SAP that are also, let's say, built in a very close collaboration together with SAP. And I think this is the reason for success. That's the reason why we can really operate in a very, very well-aligned way with our partner SAP, with Solus, and make this a very successful product approach. There was a lot of talking, so I really thank you a lot for your patience and for your interest. I hope we could generate some interest on your side. Please feel welcome to contact us anytime. So you see the contact details below. You can also book a meeting with us, and we'd be really happy to, together with our partners from Solus, to discuss your requirements for event-driven architecture and understand your needs. And we'll see if we can, let's say, make that journey together with you as well. Thank you very much for your time, and looking forward to see you maybe in the future on site at some events. Best regards. Thanks.